What a turnout for an early Monday morning session. We want to thank you for choosing our session to kick off your reInvent week. It is an honor, and we're really excited to get started here. So let's do it. So, quick raise of hands. How many of you or your teams are currently working on .NET applications or building them for years or maybe even decades? Not surprising, because the title says it's modernizing a .NET monolith, right? Now keep those hands up or raise them again if some of those applications turned into like giant unwieldy monoliths. Oh yeah, again, not very surprising. Again, going back to the title. Now raise your hands if you're currently planning a migration to AWS or it's already underway. Okay, cool. So this is a situation, not just you, most of you in the room, but also a lot of our customers outside those doors are facing. So the question is, how do you go about modernizing these applications, right? How do you modernize these applications as you move and improve those workloads on AWS, right? So this is a session where we'll explore all of those aspects when we go through Tessitura Network's recent modernization story. They walked the path, and they're here to share their hard-earned wisdom with all of you. Welcome to XNT202. I'm Jagdish Chitikesi. I'm a Microsoft Workloads on AWS Specialist Solutions Architect, and it's an honor to have with me today both Chris Shelley and Jeff Oliver from Tessitura Network. All right, here's a little bit of an agenda for the day, for the session. We'll start by a quick brief on .NET history. Then we'll get into some recommended migration strategies for you to use to migrate your .NET applications to AWS. Chris and Jeff will then share Tessitura Network's migration and modernization journey with one of their business-critical .NET monolithic applications. I'll come back and try to wrap it up with a couple of .NET modernization tools that AWS provides. And we'll try to save some time for Q&A towards the end, but if we don't have enough time, we'll be more than happy to speak with you outside those doors after the session. All right, so Microsoft released the first version of .NET of .NET Framework back in early 2002. Since then, we've seen several updates to the framework that released several new features that address the changing application development needs at the time. During this time, the size of the framework grew exponentially, but one thing that remained constant was it remained a Windows-only system. And this changed when Microsoft released a more modular, open source, and cross-platform version and called it .NET Core. It is more performant, it's more lean, it's open source. More importantly, it can run on all platforms, including Windows, Linux, and macOS. Again, since then, we've seen several revisions of .NET Core, or simply .NET, as Microsoft started calling it since .NET 5, every single year. The last major version of .NET Framework is 4.8. It is still supported, but there is no net new feature development that's happening. All the innovation and all the latest feature development is happening in .NET. You might be thinking why you're all getting a history lesson on .NET, considering most of you have a .NET background, mainly for a couple of reasons, right? So one, for the rest of this talk, when we say modern .NET, we're actually referring to the newer cross-platform versions of .NET. And two, the platforms and services that you choose on AWS directly depend on if your applications are based on .NET Framework or modern .NET. All right, so because of the long and rich history of .NET, we often see our customers having applications that just spread the gamut, right? So older .NET Framework, modern .NET, different kinds of application types. So let's dig into the options to move and improve these .NET workloads on AWS. To help us with the narrative, let us assume that you're currently working on or maintaining an ASP.NET MVC4-based web application that has SQL Server 2014 as a persistent store. Your application is a giant monolith. It still works, right? But you start seeing some cracks along the lines of performance, availability, and deployment times. Now you're planning to move this application to AWS, but you also are curious about your options when it comes to modernizing this workload and making it more suitable for being AWS Cloud Native. So even before planning a migration to AWS, what's the first thing that you would want to address with this situation? Any guesses? Your first priority should be moving to supported versions of both ASP.NET MVC framework as well as the SQL Server. Right? Both of those have expired. That is being so. Your first priority should be move to supported versions of .NET and SQL to continue receiving those security patches. Now, the 7 hours of migration describe recommended migration strategies for your .NET applications when you move them to AWS. And during this talk, we are going to focus on 3 of them, namely rehost, replatform, and refactor. So rehost is performing a very simple lift and shift transition, so there are no changes in your .NET application code. With replatforming, you're open to making small changes in your application's architecture to start reaping more benefits when you land on AWS. Whereas with refactoring, you're fundamentally redesigning your application's architecture so that you are trying to maximize the benefits that you could reap on when you move to AWS. You start leveraging more cloud-native features, thereby maximizing the benefits across scalability, resilience, and cost optimization. It is very important to note that you don't have to just pick one of these approaches and stick with it throughout your journey. You will hear later from Chris and Jeff how they picked a hybrid approach or more than one approach to solve their specific business needs. All right, let's dig in a little bit more about the rehost. So you pick the AWS infrastructure that you need for deployment. This includes picking up an AWS region and availability zone, creating and configuring a couple of Amazon EC2 instances with IaaS and SQL Server, and moving your application and database to these instances, right? So I'm oversimplifying this, but these are just the important steps that is to a rehost model. When you think about it, a simple rehost like this gives you a ton of benefits across cost, security, and management. Also note that there are over 300 instance types that you can choose where Windows is a supported OS for your .NET and SQL Server workloads, SQL Server workloads. So you have plenty of choice to pick something that is very suitable for your workloads. So to further improve your availability and fault tolerance, what you can do is you can simply duplicate your deployment across to a different availability zone in the AWS region. You create an auto-scaling group and an elastic load balancer. And then you do the same with your SQL Server. You can simply create a multi-AZ SQL Server with any of the SQL Server native clustering technologies that includes lock shipping, mirroring, or always on. And within minutes, you're going to dramatically increase your availability and fault tolerance. Now, imagine all of these benefits, but with zero platform maintenance. That's what AWS Managed Services can provide for you. So imagine moving your .NET Framework application to a service like AWS Elastic Beanstalk. It's a fully managed service that takes care of and that supports .NET Framework on Windows as a platform, and that takes care of handling provisioning, load balancing with built-in monitoring support. So by moving your monolith to AWS in a simple rehost model, you already achieved fault tolerance, automatic scaling, cost efficiency, while freeing up valuable time to actually spend on innovation rather than on platform maintenance. All right, so let's look at some replatforming options now. You have the option of replatforming your database to AWS's fully managed database service called Amazon Relational Database, or RDS for short. SQL Server is one of the supported database engines for RDS. By moving to RDS, you are actually freeing up a lot of time that is being spent on automatic maintenance and backups. You are able to get high availability with a single click of a button, and the platform provides storage and compute scalability. Another popular way to replatform your .NET applications that are bound to Windows is basically by moving to Windows containers. Microsoft worked with Docker to introduce containers to Windows developers when it introduced Windows Server 2016, a few years ago. And currently, Microsoft provides several base images for your .NET applications. Server core being the most popular one if you want a core image, a base image that supports full .NET Framework applications. Nano Server is the lightest. It is several megabytes less in size compared to server core. But the thing to note here is it only currently supports modern .NET. It doesn't support .NET Framework. So once containerized, you can now host your .NET Framework applications and move them to one of the AWS managed container services that take away the heavy lifting of managing and maintaining a container platform at scale. And the most popular managed container platforms on AWS include Amazon Managed Elastic Service, or ECS for short, or Amazon Elastic Kubernetes Service, or EKS for short. Both ECS and EKS support clusters that have Windows nodes in them that support your .NET Framework applications. How you choose between ECS and EKS depend on several different factors, and it's very specific to your business needs. Later in the session, we'll hear from Chris and Jeff how they went about choosing ECS and what are the benefits that they observe by going with the choice. Not just that, you also have the option of replacing the self-managed Amazon EC2 instances that form the nodes of your cluster with Windows Fargate. So AWS Fargate. So AWS Fargate is a serverless way to run your tasks, right? And keep in mind that with AWS Fargate, all you have to do is just provide the compute and the memory that is required for your container-based applications, and Fargate takes care of the compute. With Fargate, your Windows support is limited to ECS. Currently, that support is not available with EKS. All right, with some minor changes to your application code, you now have unlocked further cost savings and optimization on AWS. By moving to containers, you started using the benefits that it brings along with consistency and portability. With this move, you also started using AWS serverless services like AWS Fargate. After replatforming, can you now say that you've completely optimized for AWS? The answer is no, and that no might be fine with some of you if it's not hurting any of your business requirements. But to truly leverage everything that AWS has to offer, refactoring becomes crucial. It does come with a relatively higher level of effort, but on the other side, you do have an application that is completely tailor-made for AWS. Refactoring starts with transitioning from a Windows-only .NET Framework application to modern .NET that can run on Linux and other platforms. This is going to unlock numerous other opportunities for you to optimize on AWS. Apart from running on cheaper and faster Linux instances, the modern .NET is actually built from ground up to be high performant and efficient. It is also open source, which generally translates to faster development cycles. Moreover, it's well suited for cloud-native development that is using microservices or event-driven architectures with container-based deployments. And Microsoft has mentioned that .NET is where they're investing most of their time, and it is the future of .NET. All right, based on the application type, the amount of effort that is required for you to move from a .NET framework-based application to modern .NET application is different. Some .NET framework-based application types don't have a direct equivalent on modern .NET. Let's zoom into some web application types and see what the transformation looks like. So for example, the recommended approach for moving an ASP.NET MVC or an ASP.NET Web API is to move to ASP.NET Core on modern.NET, right? And it combines the previously separate capabilities that are included with MVC and Web API. For ASP.NET Web Forms, in fact, there is no direct equivalent in modern.NET, right? So the recommended path is to completely refactor to either ASP.NET Core MVC or a single page application. There is an open source effort underway that's under the umbrella of Core Web Forms, but currently it doesn't support all the features like a one-on-one when compared with ASP.NET Web Forms. All right, so we move to .NET, modern.NET. So how does that help? Right, so it opens up the opportunity for you to host your applications on Linux-based instances, which are significantly cheaper compared to the Windows-based instances on AWS. Modern.NET is also more performant on ARM-based processors. So it also opens up the opportunity for you to start using the ARM-based processors that are available on AWS with the AWS Graviton family. Based on a past internal benchmarkings, we've observed a 64% better price performance when you host your modern.NET applications on AWS Graviton processors compared to their x86 equivalents, while using 60% less energy at the same time. Now, being on modern.NET will also open up more platform choices for you, like AWS App Runner, AWS Lambda, Linux containers on AWS Fargate. AWS App Runner is the easiest way for you to move from code to a full-scale container deployment on AWS, because it has an integrated container build feature that takes your code and builds your container and spins up a complete environment for you to run your application in. AWS Lambda is our most popular serverless compute that you can use for building event-driven architectures on AWS, and it has integrations with several different AWS services. You can also start using Linux containers now on AWS Fargate. Linux containers are significantly lighter in weight compared to Windows containers, which goes really well along with the other benefits that containers have to offer. Being on modern.NET, you can now replace the Windows Fargate task with the Linux Fargate task and start using the AWS Graviton compute. Yet another approach we see customers use in moving to a microservices-based architecture for its numerous benefits across independent scaling, fault isolation, deployment times, and agile development. For the right use cases, it's well worth the effort it takes to move to microservices. Again, there are a couple of approaches that you could use. Here, the first is a big bang approach. As the name suggests, involves a complete transformation of your monolith in a single large-scale effort, often not recommended because of the risks that are involved, because of the complexity. A safer and more practical approach is going through this transition in an incremental manner. It reduces the risk significantly while providing incremental value. And this approach, we call it the Strangler Fig pattern. So let's look at the Strangler Fig pattern in action. Right? So you have your .NET monolith talking to a monolithic database. Start by introducing a proxy or a load balancer right in front of your application. Start carving out smaller microservices around the edges of the monolith and establish the communication between the proxy and the newly created service and the residual monolith, and continue doing this process until you replace the entire monolith with the newly created microservices. This is how it might look on AWS, your .NET Framework on Elastic Beanstalk, introducing the proxy, moving the static content to Amazon S3. Now start carving out new microservices, choosing the platform, moving the data that's related to a purpose-built database on AWS, and then using your proxy to adjust the routes until you replace the entire monolith with the newly created service. Right. You're definitely not on your own throughout this journey. We'll provide you help with upskilling your teams. We also provide hands-on keyboard support to our professional services wing. There are enterprise solutions-based, like experience-based acceleration that are aimed to meaningfully accelerate your journey on AWS. So it's probably clear by now that you have several options at your disposal, right? The options you choose entirely depend on the kind of business challenges that you're trying to solve. On that note, I humbly request all of you to put your hands together as I invite Chris onto the stage to talk about Tessitura's journey.
Thanks so much, Jagadish. And hello, everyone. My name is Chris Shelley. I'm the Vice President of Software Engineering with Tessitura Network. And my colleague Jeff Oliver and I are super excited to be here today to share a bit about where we are with our journey in a .NET modernization and cloud optimization with our Tessitura Network software. So today, to get things started, I'm going to share just a little bit of background on the extraordinary organization that is the Tessitura Network. And Jeff and I are going to share a bit about our stories and how we ended up here on stage in front of you today. Then we're going to talk about our rehosting effort. So as Jagadish said, there's several different phases you can go through, and we'll talk about the 3 that we selected for our process today, starting with rehosting. And Jeff will continue by talking a bit about replatforming and talk about a bit about what we think our sort of secret sauce is that's helped us be successful to this point in our journey. And I say that because our journey is not done yet. We're maybe a third of the way through all of the plans we have, and we'll share a bit about where we're going to go in the future as well, and bring it home with some great data and case stories. So to start with, Tessitura began at the Metropolitan Opera in the late 1990s. The opera had separate systems for managing how they sold tickets and how they collected contributions from their donors. And they didn't have a unified view of their patrons. They didn't know who was both donating and buying tickets. Did buying tickets cause them to donate in some cases, and so on? And so they approached their board, and the board of trustees at the Met Opera approved a $5 million investment. This is back, like I said, in the late 1990s, to build a custom piece of software. And it was purpose-built for the arts, and Tessitura was born. By 2001, there were 6 other organizations that had taken notice of what the Met Opera was doing and were very interested in using the software themselves. And so the Met said, you know what? Building software is not a core competency of an opera company. Shocking. We're going to spin this off into its own thing, and Tessitura, the platform, became Tessitura, the company, and the Tessitura Network was born. Tessitura was the first nonprofit software company built and solely dedicated to the success of the business of arts and culture, and also governed by arts and cultural organizations. So if you fast forward to today, we have 803 arts and cultural organizations in the network. We function across 3 sectors, including performing arts. This includes venues, theaters, operas, ballets, orchestras, et cetera, museums, and other attractions like zoos, aquariums, and historic sites. We are in 10 countries on 3 continents, and we serve organizations as small as regional organizations like the Kansas City Repertory Theater, all the way up to some of the largest and most prestigious arts organizations in the world, such as the Metropolitan Opera, the Royal Opera House in London, Sydney Opera House, Carnegie Hall, the Royal Collection in the UK, and so on. You may have heard of some of our competitors like Blackbaud, Ticketmaster, Salesforce, and so on. And one of the things that's unique about Tessitura, you've heard me call them our members, and that's because, like I said, we are a 501c3 organization ourselves. We are governed by a board of leaders from the arts organizations that we serve. And in fact, today we actually are honored to have one of our organizations in the audience, the Pittsburgh Cultural Trust, and Dan Hoffer, their CEO, is on our board. So we're a co-op wholly owned and governed by our users. It's kind of unusual, right? Our users are actually our bosses. So Jeff and I are going to share a bit about our stories and how we ended up here today with you. My story with Tessitura starts a little over 9 years ago, and our rapid success as a company meant that we were quickly outgrowing our existing technology stack and our deployment models. We were being forced to clean up issues as they occurred, rather than thinking about solving problems upstream and really sort of modernizing our infrastructure. This is something that Dan Heath, the author, calls upstream thinking in his book, Upstream. If you haven't read it, it's a fantastic book. Digital transformation, and what Jeff and I are talking about today, is a prime example of thinking about how you solve your problems upstream rather than focusing on being good cleaner-uppers. And Jeff will share a bit about his story with Tessitura.
Hey everybody, my name is Jeff Oliver. I'm the Vice President of Hosting Services at Tessitura. I'm so happy to be here, and thanks for taking time to be with us. My journey at Tessitura started about 4 years ago in December of 2020. I was having lunch with a longtime friend and colleague who was transitioning off a consulting project and thought I might be interested in getting involved. After listening to him describe the project, I said, John, let me get this straight. You're migrating a legacy co-location VMware architecture hosting 600 customers on 3 continents to AWS in 5 regions. The target architecture is 100% Microsoft workloads running on dedicated hosts and served up primarily via Citrix. And you have to execute the migration in less than 10 months to avoid another year of co-location expense. He said, yeah, what do you think? I said, it sounds really expensive. How long are you going to have to re-architect to be more cloud native before the economics become problematic? And he looked at me and he said, about 3 years to contain, and then about 2 to 3 more years to make it sustainable. Are you interested? And here I am. We're in year 4 now. The migrations actually did complete on schedule. Our cost ratios are starting to turn in the right direction, and we sustain about 45% growth as a company since then.
So since the title of the presentation is the art and culture of modernizing a .NET monolith, let's talk about our .NET monolith. So from the beginning, our platform has been a traditional client-server model application utilizing Microsoft technologies. We have a client application that's a Windows desktop application, again, using the legacy.NET framework. And it was also built using a platform called Power Builder. Show of hands, anybody heard of Power Builder? Oh my gosh, my people.
Wow.
I had no idea. The next line in my notes is, oh yeah, I thought it was going to be a small group. That's so many people. I was shocked, actually. So that client application, traditionally in our history, has had a direct connection to a Microsoft SQL single-tenant database. That client application is what's used by like ticketing office personnel, fundraising professionals, and so on to actually do their jobs at work, right? So that's our client application. We also have an e-commerce application that we have member organizations that don't want to build their own web property using our API. They can pay us, use our white label application, and use that to sell tickets online, display their events, collect contributions, and so on. This was also a .NET Framework application from the beginning using web forms. That communicates with our SQL database using a .NET Framework API, again, legacy.NET Framework in the beginning. We also have a business intelligence application for data insights and dashboarding that we bring into our client application for our users to build business intelligence reporting. That has a proprietary data warehouse in the back end from the third-party provider that provides that data warehouse and business intelligence application for us. We host that ourselves today, and all of these components connect back to our Microsoft SQL database as the main sort of data layer of our application. So in 2016, in our Dallas data center, this is a simplified view of the architecture that we had. The components were all, and still mostly are, single tenant. So every member gets their own deployment of the Tessitura application. The infrastructure, however, is mostly shared. So we have multiple members sharing one stack of infrastructure that includes a database host, API hosts, and so on. In this architecture, there were no high availability options. Members could only have one production instance of their database. This sort of Windows client server model is very much an architecture of its time, right? Back when we started in the early 2000s, this was the bee's knees. Super durable architecture. It served us really well for 20 years. It continues to serve us well in many ways. But today, there are better ways. And that's why we're on this modernization journey. So to minimize change, maximize learning, and ensure stability, we chose the multi-step process that Jagadish was talking about earlier that matches up roughly with that strangler fig pattern that you saw. We would start with rehosting, then move on to replatforming and building out some microservices, and then do refactoring at the end. Now, you'll see that we kind of mixed and matched a little bit early in the process. We actually did some refactoring kind of throughout for different reasons, and I'll explain why we chose to do refactoring at a few specific moments in our journey to this point. So starting with rehosting and the move from the Dallas data center to the commercial cloud with Amazon, this was a pretty standard lift and shift operation, right? And probably a lot of you are familiar with this. When you take an on-premise hosted solution, you just want to park it in the cloud. You're making very few, if any, architectural changes to what you're doing because the goal is to just get into the cloud, right? And if you make a whole bunch of changes along the way to try and cloud optimize, that can really delay your timeline. It can delay all the value that sort of stands behind that wall in the cloud. And so we wanted to take on minimal architectural changes when we moved. This enabled completion in a really timely and affordable way without introducing an untenable amount of change for our team and our members. This was possible, though, because of two key elements. One was an offering from Amazon called Dedicated Hosts. I'm not going to get into the details about Dedicated Hosts, but just know that it's a program offering that really enabled us to get to the cloud in mostly a cost-neutral kind of way because of Windows license mobility. Thanks to Microsoft's licensing rules at the time, we were able to bring our own on-premise Windows servers licenses purchased prior to October 1st, 2019, to our dedicated host environment in AWS. And so this was our architecture after rehosting in 2021. Dedicated hosts were used for our compute workloads, which took advantage of Windows license mobility, like I just said. This looks really similar, right? That's because, like I said, it's a lift and shift. We didn't make hardly any changes when we moved to the Amazon commercial cloud. Dedicated hosts had a trade-off, though, and due to restrictions with Microsoft's licensing, we wouldn't be able to purchase new licenses or upgrade existing licenses for our dedicated host environment after October of 2019, which is not good for growth, right? We've already covered we're experiencing sort of this period of very rapid growth. So, we knew this was going to be a problem for us, and this encapsulates what we are calling the dedicated host puzzle. Now, don't take pity on us. We knew all this going in, right? We understood that this problem was going to occur at some point, and we'd have to figure this out. The way out of this was going to be the refactoring that we're going to talk about here as we progress through our discussion today. We had to do that replatforming and refactoring in order to start taking advantage of all the benefits that the commercial cloud has to offer, right? Things we all know, like scalability, optimized resource utilization, improved development capabilities, and more. And dedicated hosts didn't allow us to take advantage of any of that. They were simply a tool for us to get from point A to point B in a timely fashion, in a cost-neutral fashion. We did do a bit of light refactoring along the way, and the reason we did this was because we felt that it was very important for our teams to start learning ahead of time before we actually had sort of a real organizational need about the technologies that they'd be seeing in the future as we worked with the Amazon commercial cloud. So this is things like working with Elastic Beanstalk, working with dynamic deployment code, working with infrastructure as code, working with technologies like DynamoDB and document-based storage, right? Giving our team space early where the risk was low for them to learn in a safe way was super important for our team. That way, when we got to the point later where we really needed to do the refactoring for cost purposes because of our timeline, they already understood the tools that they were going to use. They could see the opportunities and engage those tools to solve the problems without having to go back us up months at a time to learn those technologies. So, of course, there is no learning without mistakes, and I want to talk a little bit about a couple of toe stubs here that we had along the way, because there's no learning without fits and starts. And they really center on two different areas. One is data management, and one is deployments. As I said earlier, we are a Microsoft SQL shop, and one area that it took a good amount of learning for the team to really understand how to utilize the technology was with DynamoDB. Moving from a relational database environment with Microsoft SQL to the way that Dynamo handles things in a schemaless sort of fashion was a really big mindset shift for a team of engineers that had been working in sort of this very structured relational mindset for so long. They were able to work through provisioning and how to properly structure the data so that it was properly indexed. That experimentation led us to be able to capitalize on the value that Dynamo had to offer, and we continue to expand our Dynamo usage for new workloads. We're not replacing legacy workloads with Dynamo today. When we have new data storage needs that match up with what Dynamo offers, we usually engage Dynamo to solve that problem. We also engaged in a program called a data lab with Amazon. It's actually no longer offered, but at the time, the program was specifically geared toward helping organizations migrate workloads from Microsoft SQL to open source database technologies like PostgreSQL. So in this case, that's what we were trying to do. This is a conversation that comes up about every 8 months at our organization. Like, shouldn't we consider leaving Microsoft SQL and going to an open source database? Surely this should be fairly straightforward for us to do. And we had never really taken many steps to try and do that. So this data lab was a great opportunity for us to explore that. And we learned pretty quickly into that week that this was going to be much harder than we thought. So we use a lot of deeper, more intricate features of Microsoft SQL Server because we've been using it for so long. And as a result, a lot of the automated tools that are offered didn't really do the job for us to do this in a very fast way. That may be different for your organization, so I don't want to say that those tools don't work. For us, they didn't work because of the way we use Microsoft SQL Server. For you, they may work great, and so I'd still encourage you to try some of those tools if you're looking to migrate from Microsoft SQL. So that one, warning sign, didn't really work out. But we did learn that we were going to have to be much more intentional about that move if and when we decide to take it on. And you'll hear later that we're actually kind of doubling down on Microsoft technology for now to solve some other issues that we have. And so then the second area of learning for us was really learning to work with infrastructure as code, right? Starting with CloudFormation, our team was able to start building infrastructure as code, storing that in a repository, storing it with the applications that we were deploying. In this case, it was using an Elastic Beanstalk application that had a Dynamo database behind it for storage. We were working with auto-scaling. That evolved with the team into using the CDK, Cloud Developer Kit, with C#. That felt much more natural to our team as a natural sort of next step into working with deployments as code. And so today we use CDK for all of our infrastructure as code deployments, and it's a very natural fit for a team of object-oriented developers that have been using C# for a long time. And so that's been a good shift for us. So after rehosting, it was time to take on some replatforming. And this is where we start talking about things like containerization, moving from Windows to Linux, and so on. To aid with replatforming, we did refactor 2 of our components from legacy.NET to modern.NET. This enabled us to skip directly to operating over Linux containers, and we didn't stop over and utilize Windows containers as sort of an interstitial step. Skipping this was a good decision for us, and it went really smoothly. We had a team of hosting engineers that had some concern and expressed that concern about skipping directly to Linux because they didn't have a lot of on-team experience there. But due to the technology choices we had available to us in AWS, it abstracted away a lot of the complexity of having to learn the Linux platform and administer components on our network that utilized Linux. And so this actually ended up being a great step for us. And it's been going very smoothly. Knock on, there's no wood up here. I got you. Anyway. So with the lift and shift complete, where do we go from there? This is all the refactoring that I was talking about. So together, Jeff and I worked on a roadmap to sort of get us out of this dedicated host conundrum and replatform and refactor some of our system components. The first step is migrating to a web interface for the client application. So we need to get out of that Windows application environment, move to a browser-based client application. This transition from a Windows client to a web client allows us to leave Citrix behind. So we're actually using Citrix to serve up that Windows client to our users that host the platform with us today. I didn't mention this earlier, but from our beginning, our member organizations actually have the choice to host our platform entirely on their own. So they don't have to have us host it for them. Starting in about 2009, we introduced a hosted offering that allowed us to host the platform for our members. Today, we have about 83% of our members that host with us, about 17% that don't. So moving to a web-based client allows us to eliminate those Citrix hosts and reduce cost. Citrix is also one of the most fragile components of our network and is responsible for a lot of the support tickets that we get, so we also eliminate those. Next, we were going to be containerizing several of our server components. This is refactoring and replatforming to modern.NET into Linux containers instead of Windows.NET .NET Framework applications. It addressed the licensing cost challenges that we had with Windows. It moves the e-commerce and API applications that I talked about to Linux containers. This gives us cost savings through auto-scaling, reducing over-provisioning. It also gives us improved system capacity and performance and eliminates a fleet of dedicated hosts. The transition to Linux was made easy with Elastic Container Service, and we chose ECS because it really struck the right balance for us between cost, complexity, and abstraction, right? So with all these decisions with AWS services, you're considering, all right, how much is this going to cost us? What kind of complexity are we buying when we start working with this service? And then what kind of complexity does it help abstract away from our team by using that service? And in this case, Elastic Container Service struck the right balance for us. We also looked at EKS, or Elastic Kubernetes Service, and Fargate. But again, they were sort of at other ends of the spectrum, and we felt like sort of that place in the middle was really the right place for us. Next, as I said, we're going to be implementing SQL Server Enterprise. This allows us to meet our recovery time objectives is one of the primary reasons we're going this direction. It also allows us to continue building sort of that multi-tenant infrastructure architecture that we have, where we have single-tenant deployments for all of our members, but we have multi-tenant infrastructure that we host them on, so we can have multiple member databases on the same SQL hosts. And lastly, we're migrating that analytics application to our provider's managed services cloud. And we're going to be taking that project on this year. As part of that project, we're replacing their proprietary data warehouse with Redshift and data migration service, or DMS, with Amazon. And early testing with that indicates that we're going to see some really significant performance and cost savings there by moving to DMS and Redshift and away from the proprietary database technology that the vendor provides. So all of this effort is to get us into a more cloud-optimized state and get us out of that dedicated host conundrum. And I'll turn it over to Jeff here to bring it home with more about replatforming and some case studies.
Thanks, Chris. By now, you've probably caught on to the fact that our journey to AWS has been a combination of the 3 R's that Jagdish touched on earlier in the presentation. First, we rehosted the platform with minimal changes. Along the way, we opportunistically refactored the monolith into some microservices. And this approach has given us some early success and valuable experience with the AWS toolset, which is now helping us fuel the replatforming journey that I'm going to cover in the next few slides. The journey starts with the most important thing, our team. Team culture matters, and we believe that 3 of our core values have been key contributors in our cloud journey. These values aren't meant to be prescriptive, but perhaps they resonate with you. First is resilience. We need teams that can handle change and disruption. People come and go, teams are reorganized, and priorities shift. To manage this, we cross-train, share knowledge, distribute on-call responsibilities, and promote work-life balance. We do this because we believe that resilient teams build resilient systems. Psychological safety is a priority at Tessitura. We need team members who feel accepted coming to work as themselves. We need honesty and risk-taking. And we need to hear from the talented people we've hired about their questions, ideas, and their concerns. How else could we improve? Innovation requires learning and experimentation, as you probably know. At Tessitura, we follow the see one, do one, teach one approach to learning. We allow team members to spend up to 10% of their work time on relevant learning activities. And this has helped us increase our AWS certified engineer base from less than 10% to over 60% of our engineering staff in under 3 years. We use these skills in our daily AWS work and encourage teaching through weekly seminars and dedicated teaching time during in-person meetings. And we put these values to work. Here are a few of the tactical ways that these core values have contributed to our transformation so far. First, we build T-shaped alignment, broad across leadership and deep within our teams. Starting with the team, we connect strategic projects to impacts on day-to-day work and give them space to absorb that challenge. And from there, we build alignment across the organization, because without that alignment, we wouldn't be able to execute on these projects. Next, don't underestimate the impact of well-placed evangelists. To build autonomy and strengthen the fabric of each team, we needed people who had experience that could help guide and support from within. And finally, we struggled approaching the transformation from a perspective of paying off years of technical debt. Tech debt had become weaponized. It's kind of the thing that people didn't like about the software, rather than issues that had real costs and would result in tangible returns. We had to change our perspective from focusing on fixing all of our tech debt to making strategic investments that have a meaningful impact on cost optimization and operational excellence. We had to stop feeling bad about where we were and start focusing on the benefits of where we were headed. In fact, it was that investment mindset that pulled into focus the 4 main pillars of the replatforming plan that Chris touched on a few slides ago. Together, we focused on optimization to improve efficiency as the platform scales. And AWS services, 71 of them, as of the invoice that I got yesterday, have helped us along the way. This optimization generally falls into 3 categories. First, we strive to ensure that managed assets are codified with services such as CloudFormation, CDK, and X-Ray. Second, we reduce ClickOps work through automation with services such as Service Catalog, Image Builder, Code Deploy, and Systems Manager. And finally, we closely monitor and optimize our spend by leveraging services such as savings plans, data exports, Trusted Advisor, and QuickSight. For us, optimization is about maximizing the value of staff time and driving down our per-member unit costs so that our time and cloud savings can be reinvested. And as a nonprofit, this is how we achieve sustainability for our business and for our members. Part of our platform is live event ticketing. Sometimes when a member organization has a high demand on sale, like the national tour of Wicked or Hamilton, they need to quickly scale up to meet that demand. And so the first challenge is that traffic patterns are erratic. Because of our dedicated host architecture, horizontal scaling was not available to us without complicated orchestration and planning. And so we provisioned hosts that could handle a much higher capacity in the event of a spike in traffic. With our shared infrastructure, this also opened the door to noisy neighbor problems, where one member has an on-sale and uses a disproportionate amount of resources, and that leaves other member sites resource-bound. Additionally, some members utilize resources more in their day-to-day state than others, so a one-size-fits-all solution was not optimal. We also provide every member a production and test instance of the e-commerce platform. And across the platform, we see these test workloads running at about 10% or less utilization. Add up those conditions and you can see why we were significantly over-provisioned using dedicated hosts. And so we've introduced ECS to manage our e-commerce workloads with plans to expand to other workloads in the future. Now, in order to execute this maneuver, we knew we couldn't do it alone. We had to leverage partnerships to augment our team capabilities, upskill our engineers, and help us rethink how our teams work together. I'm sure most of you are familiar with Conway's Law. To paraphrase, it states that the structure of the software will mirror the structure of the team that built it. And we were no different. Since the introduction of our hosted offering in 2009, we've had separate software engineering and hosting engineering teams. For the most part, the software team built the software, the hosting team managed the deployments. We had outgrown that model and started to experience some of the problems that come with separating the two. And so our AWS team suggested a program they offer called the Experience-Based Accelerator, or EBA. The EBA program was specifically designed for teams that not only want to re-architect a platform component, but also want to evolve how their teams work together. Our program was 6 weeks. We aim to build a reusable container deployment completely with infrastructure as code and successfully deploy that infrastructure to a single member site in our Asia Pacific region. We also wanted to pilot a cross-functional team of stakeholders and builders that were well positioned to make decisions about the work in an autonomous way. We fell just short of the final technical objective, but we saw a lot of magic happen with the teams. And I don't really know why the pirate theme happened, but that wasn't part of the magic. We were able to build knowledge, efficiency, confidence, and trust, most importantly, as a template for future team interaction that we'll use throughout the program and into the future. So in the first half of 2024, we carried these lessons from the EBA forward and completed the deployment of the solution. And here's what the architecture looks like today. Now, on the diagram, it's a very small change. It looks small, it wasn't, but it's paid off for us in several ways I'm going to touch on briefly. So let's take a deeper look at some of these outcomes. First, let's look at performance. Our initial testing results, honestly, were mixed. Total and peak requests were slightly lower, but roughly equivalent. But response times were about 10% slower. This surprised us enough to trigger some additional work, and thanks to ECS and our infrastructure as code approach, it was relatively quick and painless to do that. And after this work, some improvements were made in both dimensions, but especially response times, where we saw overall from baseline an improvement of about 25%. And what about cost? When comparing daily compute cost per member, we're seeing about a 54% reduction with containers versus the legacy architecture on dedicated hosts. This represents an overall reduction in our monthly spend of about 4%, and it doesn't even include the cost of Microsoft licensing that we're saving by moving to .NET on Linux. Nor does it account for other exciting changes coming down the line for us, specifically Graviton. And so overall, here's how our e-commerce workload replatform with ECS has addressed the challenges. Compared to Windows deployments on dedicated hosts, an initial container deployment has come in at about 54% savings. This is because we are no longer over-provisioned and scale to meet demand as needed. Thanks to auto-scaling, we also have a solution that right-sizes itself automatically to each member's needs. And because each member has their own isolated deployment, we eliminate that noisy neighbor problem. I want to wrap up by sharing a story that really brings the impact of all of this work home. So, as many of you know, in the early morning hours of July 19th, many of us changed our plans for the weekend. And I'm not here to talk about CrowdStrike. I'm here to talk about our team, so let's be clear about that. It's a great story for illustrating so many of the benefits that I've touched on today and how our members are already experiencing some of those benefits. At Tessitura, we had about a dozen engineers working to fix roughly 1,600 impacted instances across the platform. At the same time, we deployed a small team of engineers to work on scripting the updates so that we could eventually automate the fixes in batch. By the time we finished the automation in the evening hours of Friday on US Central Time, we had approximately 30% of production and all of our non-production environments left to go. Using the automation, we had 2 engineers that were able to finish the rest of production and all of our test and development environments. That brought us to full operational capacity by about 3:30 a.m. US Central Time on Saturday morning, just over 24 hours after the original issue manifested. Now, in addition to higher recovery rates per engineer, we found the automated fix had a much lower rate of failure. The manual process often required us to abandon the fix and recover from backup, which added to time and complexity of the recovery effort. All of this work that Chris and I have been talking about today, collaborating across teams, infrastructure as code, automation with cloud-native technologies, is wrapped up in this story. And each of those things were pivotal in driving our team's ability to recover from this incident in 26 hours rather than days or weeks, which was the case with many organizations. Writing infrastructure as code has real benefits for our members. We were able to come back to full capacity much more quickly than we otherwise would have, which in turn significantly reduced the impact of the incidents on arts and culture organizations around the world. So that's our story so far, and the road ahead involves a continued evolution of all 3 of the migration patterns that we've touched on today. First, we actually have some rehosting left to do. Chris touched on this earlier. We're focused on building a platform that will support 100% of our members, and we're well on our way to achieving this goal. We're at about 83 to 85% of members today choosing our cloud offering over self-hosting. The remaining member environments tend to be very large and complex, which makes migration to the original architecture really untenable, due in part to an even greater need for scalability and elasticity for things like exceptionally large on-sale events. That's where the continuation of the replatforming journey comes into play. With ongoing help from our AWS partnership, our plan is to re-architect additional workloads to a more sustainable and resilient platform. Areas of focus here include containerization of the API and possibly, arguably, a move of our database workload to Postgres on something like RDS or Aurora. But that is not a today thing. That is a down the road, if at all. By doing so, we aim to continue to drive down our cloud spend per member while continuously improving on our resilience objectives. And finally, we're planning a number of refactoring initiatives. Namely, we're re-architecting our analytics platform next year, which will include a move to Redshift and DMS, as Chris mentioned earlier. And we're looking at other possible microservices as well. As Chris once said to me, no plan survives its collision with reality. But as we look to our architecture plan and consider all the initiatives that we've covered today, here's the target state we're looking at: rehosted, replatformed, and refactored for the future in the infinite game of our cloud journey. That's all I've got, and then I'm going to hand back to Jagadish.
Yeah. Thank you, Chris. Thank you, Jeff, for sharing that amazing journey. I cannot wait to continue working with you as you try and execute your roadmap for the new year. All right, I quickly want to wrap it up by introducing a couple of modernization tools that we provide for .NET applications. The first is apt2container. How many of you here heard about apt2container already? Some of you. Okay, for the rest of you, it's a command line tool that will help you lift and shift .NET applications that are currently hosted on virtual machines on premises or on AWS. It automates the way you containerize them and then move them to AWS managed container platforms like ECS, EKS, or AWS App Runner. It supports several versions of Java and .NET, so it's a really good tool to use if you're looking to quickly automate your containerization and then moving to AWS. And the second tool I want to introduce for .NET modernization is the AWS microservice extractor for .NET. This is a standalone tool that you have to pull down the bits and install, and then it simplifies the process of extracting microservices from your .NET monoliths into a microservices-based architecture. Right? So it does that by scanning your code. It is going to look at the static and runtime dependencies between different parts of your code base, and then come up with a default grouping of what we call components that can be extracted as an independent microservice. And finally, it'll go one step ahead and actually help you with the eventual extraction. So this is a screenshot from the tool that shows the visualization between different components within your code. Microservice extractor uses a machine learning model behind the scenes to come up with the default grouping of components that it thinks is suitable to be extracted as a microservice. But as developers, you will have the option to fine-tune them and adjust the components to fit your needs. All right, that brings us to the end of this session, but hopefully it is the beginning of your modernization journey. Just a few things to note if you don't already know. There is an army of .NET specialists at AWS, so do reach out to your account teams if you need conversations, if you need some brainstorming for your applications. We can definitely do that. We also have some very curated programs that address your modernization journey. And again, a good starting point is your AWS account teams. There is a Windows SQL Server and .NET booth on the Expo floor. So if you have any questions, do bring it to us to the Expo floor. It's open throughout the week. We'd love for you to stop by. And we did not cover SQL Server modernization, we see that very frequently associated with .NET workloads. So I'm leaving a QR code up there that talks a lot about how you can modernize your SQL Server workloads. The other QR code is the landing page for everything that you need to know about .NET on AWS. All right. Thank you so much for your time and taking time and actually attending our session. Have a fantastic rest of your week at re:Invent, and I'll hope to see you again.